Science in Action. Science in Action is produced by the West's oldest scientific institution, the California Academy of Sciences, now in its 100th year.
Thank you. May I pour you a cup of coffee? While I'm doing this, I'd like to mention a problem that has arisen. Now, I didn't plan to drink my coffee right now. What I had hoped to do was to drink it in a few minutes. So the question is, shall I add the cream now, or shall I add it later, say in about 5 minutes when I get ready to drink the coffee? Well, we can very easily make an experiment out of this by adding cream to one of them now, and then later, when we get ready to drink the coffee, we can test that against the other cup of coffee to which we will add cream at that time. Now, of course, there will be a certain amount of cooling in both of these cups of coffee, and that cooling will be due to the flow of heat. Flow of heat from the coffee to the cup and from the coffee to the air. Now, there will be a considerable amount of difference in the temperature of those 2 cups of coffee in 5 minutes. I have difficulty remembering which one cools off the faster. But fortunately, we have as our guest on Science in Action a scientist who has the answers to all such problems. I'd like to have you meet him. He's an old friend of our program, Professor of Physics at the University of California, Dr. Harvey E. White. How are you there, Harvey?
Good evening, Earl.
Say, can you help us with this coffee problem?
I'm not sure about all the answers, Earl, but we'll try on this one.
Fine.
Here's a little diagram made up of 2 cups of coffee. This one hasn't had the cream added. It's black yet. This is the one to which cream has been added. Now, this cup here that's black started at the same temperature this one did, but being hotter, it cools off more rapidly. And we can show that with a little graph here. Oh, this represents the cup of coffee that's black. It cools off with time, so that in about 5 minutes, 4.5, 5 minutes, it's gone down almost to room temperature, but not quite.
This would be the time scale here in minutes, 1, 2, 3, 4, 5.
That's right. Now let's look at this cup. The first thing we did was add cream.
Yes.
Right away, that cooled it down from this temperature down to about there. Then it started cooling, but being now cooler than the other one was, it doesn't give out as much heat per minute, and it follows a curve that looks similar, but always stays below the other one, goes along like this.
Oh, yes.
But now don't forget, we haven't added the cream to this one yet.
Oh, yes, the first one.
So now if we add the cream here at this point, it cools down below the other one and goes on.
Oh.
So now if you want your coffee to be hot at the end of 5 minutes, are you going to add the cream first or at the end of the time?
Well, the thing to do, quite obviously, from this graph is to put the cream in first, and at the end of 5 minutes, you'll have the hotter coffee than if you added the cream at the end of that period.
That's right. Just the opposite from what you might think.